Hello students, this is chapter 1 of class 10, Chemical Reactions and Equations. This is part 3 of my presentations. In this, we are going to study oxidation and reduction reactions, exothermic and endothermic reactions, and we are going to revise all those reactions which are important from examination point of view. Let us learn about oxidation. Oxidation is a process in which oxygen or an electronegative element is added to an element or a compound. It can be also defined as a process in which hydrogen or an electropositive element is removed from a compound. In terms of electronic concept, it can be defined as a process of loss of electrons from an element. If an element loses electron, the charge on the element will increase. So the oxidation number will also increase. Let us study this by examples. In the first example, we can see sodium combines with oxygen. So this is oxidation of sodium to sodium oxide. In the second reaction, chlorine, which is an electronegative element, combines with Fe. So this is oxidation of Fe to FeCl3. In the third reaction, hydrogen is removed from CH3CH2OH, which is ethanol, to form ethanol, CH3CHO. So removal of hydrogen is oxidation again. In the fourth reaction, an electropositive element, mercury, is removed from Hg2Cl2, leading to oxidation of Hg2Cl2 to HgCl2. And in the last, we see aluminium, after losing 3 electrons, gains 3 positive charges. So this results in increase in oxidation number of aluminium from 0 to 3 plus. So again, this is oxidation. Let us study what is reduction. Reduction is just the opposite of oxidation. Reduction can be defined as a process in which oxygen or an electronegative element is removed from a compound. It can be also defined as a process in which hydrogen or an electropositive element is added to an element or a compound. In electronic concept, it is a process in which there is gain of electrons by an element. If an element gain electrons, the charge on the element will decrease. So the oxidation number of the element will decrease. Let us study this by examples. In the first example, we can see copper oxide loses oxygen. So this is reduction of copper oxide to copper. In the second example, we can see AuCl3 loses chlorine, which is an electronegative element. So loss of chlorine is reduction of AuCl3 to AuCl. In the third example, we can see addition of hydrogen to sodium is reduction of sodium to NaH. In the fourth example, we can see addition of an electropositive element copper to CuCl2. So this is reduction of CuCl2 to Cu2Cl2. And in the last, we can see an electron is added to Fe3+. Addition of electron decreases the charge on Fe3+ to Fe2+. So the oxidation number is decreasing, and this is again reduction of Fe3+ to Fe2+. In the previous 2 slides, we have studied about oxidation and reduction reactions. Let us now look at what are redox reactions. Redox, as the name suggests, are chemical reactions in which oxidation and reduction take place simultaneously. The reaction between MnO2 and hydrogen chloride is a redox reaction. Here, MnO2, after losing its oxygen, is reduced to MnCl2. On accepting this oxygen and by losing hydrogen, hydrogen chloride is oxidized to water. Another classic example of redox reaction is rusting. Rusting is corrosion of iron in presence of oxygen and water. So a hydrated molecule of iron oxide is rust. To understand redox reaction, we are just studying the reaction between iron and oxygen. Iron and oxygen form three types of oxides: FeO, Fe2O3 and Fe3O4. Here I am just taking the example between iron and oxygen to form Fe2O3. The reaction looks simple oxidation of iron. What happens to oxygen? To understand this, let us study the electronic concept behind the reaction. A single atom of iron, after losing its 3 electrons, gains 3 positive charges on its atom. But a single oxygen atom can accept only 2 electrons and can gain 2 negative charges on its atom. So, 2 iron atoms lose their electrons so that they can be accepted by 3 oxygen atoms. The iron and oxygen atom, because they gain opposite charges because of this exchange, attract each other and forms a bond, resulting in one single molecule of Fe2O3. We have already studied about the substance oxidized and the substance reduced in redox reactions. Now we are going to understand what are oxidizing and reducing agents in a chemical reaction. For this, we are taking an example of the reaction between zinc oxide and carbon, which produces zinc and carbon monoxide. In this reaction, zinc oxide is reduced to zinc by losing its oxygen. The other component present on the left side of the equation is carbon. So, carbon becomes the reducing agent for zinc oxide. Similarly, carbon on acceptance of oxygen from zinc oxide is oxidized to carbon monoxide. The other component present on the left side of the equation is zinc oxide. So this becomes the oxidizing agent for carbon. Let us take one more example to understand the concept more clearly. This is a displacement reaction between zinc and copper sulfate to produce zinc sulfate and copper. In this, we can see zinc has an oxidation number of 0, which increases to 2 when it becomes zinc sulfate. So this is oxidation of zinc to zinc sulfate. The other component present on the left side of the equation is copper sulfate. So copper sulfate becomes the oxidizing agent for zinc. Similarly, copper in copper sulfate has an oxidation number of 2, which is decreased to 0 on the right side. So this is reduction of copper. The other component present on the left side of the equation is zinc. So zinc becomes the reducing agent for copper sulfate. There are many oxidation and reduction, or to say redox reactions, occurring in our daily life that go unnoticed by us. Few examples will surprise you that these are redox reactions. Burning of fuels is a redox reaction. CH4, which is natural gas, is oxidized to CO2, and oxygen in return is reduced to water. Besides knowing the substance that is oxidized and the substance that is reduced in these reactions, the color of the products also sometimes changes, and they are important from examination point of view. Let us study some of these examples which are important from corrosion of metals. Silver on reaction with sulfur. Silver is oxidized here and sulfur is reduced to form silver sulfide. which develops a black coating over silver articles. The reaction between iron, oxygen and water forms hydrated molecule of iron oxide, which is a brown rust over iron articles. Similarly, the copper on reaction with oxygen forms a black coating of copper oxide. Here, copper is oxidized and oxygen is reduced to form copper oxide, which is black in color. This on further reaction with carbon dioxide changes the color of substances to green because of the product copper carbonate. Here, copper oxide is reduced and carbon dioxide is oxidized. Other than the change in color in products, sometimes the taste and the smell also changes. Fats and oils present in the food are oxidized because of redox reactions and they develop a rancid smell and taste, which is unacceptable. Respiration, which is a life process of all living organisms, is also an example of redox reaction. In this reaction, the carbohydrate molecule is oxidized to carbon dioxide and oxygen molecule is reduced to water. Reactions can also be classified in two categories, exothermic and endothermic reactions. Exothermic reactions are those reactions in which heat is liberated or released along with the formation of products. Let us study some of the examples which are given in NCERT textbook. The first example is burning of natural gas. In this, methane, when it combines with oxygen, produces carbon dioxide, water, and heat. Basically, all fuels on ignition produces heat, and that is why they are used as fuels. The second example is respiration in organisms. In this, the carbohydrate or glucose molecules, when it combines with oxygen, produces carbon dioxide, water, and energy. This energy is utilized by organisms for various activities. The third example is decomposition of vegetable matter into compost. This again is an exothermic reaction. Now let us study what are endothermic reactions and how are these reactions different from exothermic reactions. Endothermic reactions are those reactions in which heat is absorbed. Let us recall from my earlier presentation of Chapter 1, Part 2, where we have discussed about decomposition reactions due to heat. These decomposition reactions are also known as thermal decomposition. Let us study some of the examples of thermal decomposition. The first example is iron sulfate, which is green in color. Because of heat, loses its green color and forms Fe2O3, SO2 and SO3. The second example is calcium carbonate. On reaction with heat, produces calcium oxide and carbon dioxide. Calcium oxide is also known as quicklime, which has many uses in industry. One such use is in the manufacturing of cement. The third example is decomposition of lead nitrate due to heat. It produces lead oxide, nitrogen dioxide, and oxygen. Nitrogen dioxide can be identified by its color of brown fumes. Let us revise some of the important chemical reactions from this chapter, which are important from examination point of view. The first reaction is burning of magnesium ribbon. In this reaction, magnesium combines with oxygen to produce magnesium oxide. It is a combination reaction. The color of magnesium oxide can be asked, which is white powder. Magnesium burns with a dazzling white flame. The other question that can be asked is why magnesium ribbon needs to be cleaned before doing the reaction. It is because magnesium is a reactive metal and it combines with oxygen of air to produce magnesium oxide. So a white powder deposits on magnesium ribbon, which needs to be cleaned. From the second reaction, the common name of calcium oxide can be asked, which is quicklime. And the common name of calcium hydroxide can also be asked, which is slake lime. Let us see how calcium hydroxide is produced. Calcium oxide, on reaction with water, produces calcium hydroxide. This is a combination reaction. Calcium hydroxide is used for whitewashing. When it is used on walls, it reacts with carbon dioxide of air and produces calcium carbonate. In 2 to 3 days, it gives a shiny appearance to the walls. Calcium carbonate has 3 forms: limestone, chalk, and marble. This calcium carbonate can decompose because of heat, producing calcium oxide and carbon dioxide again. So this is an example of thermal decomposition. The other reaction which is important is thermal decomposition of ferrous sulfate. It is because in this reaction, the green color of ferrous sulfate disappears, forming iron oxide, sulfur dioxide, and sulfur trioxide. The fourth reaction which is important is thermal decomposition of lead nitrate. When lead nitrate reacts with heat, lead oxide, nitrogen dioxide, and oxygen are produced. Nitrogen dioxide has characteristic brown fumes, which can be asked. The fifth reaction is photolytic decomposition of silver chloride. When silver chloride reacts with sunlight, it produces silver and chlorine. But the color of silver changes to gray. And this important reaction is used in photography. The sixth important reaction is electrolytic decomposition of water. When electricity is passed in water, hydrogen and oxygen are produced. The questions that are asked are how many parts of hydrogen and oxygen are produced and on which electrodes they are produced. So the answer to these questions are 2 parts of hydrogen at the cathode and 1 part of oxygen at the anode are produced. Another important reaction is a displacement reaction. The reaction is between copper sulfate and iron. When iron nails are dipped in copper sulfate solution, FeSO4, iron sulfate, and copper are formed. Copper sulfate has a characteristic blue color. This color fades and it changes to brown with this reaction. Another important reaction is a double displacement reaction between sodium sulfate and barium chloride. When these compounds react, barium sulfate and sodium chloride are produced. Barium sulfate, which is formed, is a white precipitate. Precipitate is an insoluble state. So all these reactions which we have studied are important for students to be revised. I hope you have understood the chapter and seen all the 3 videos, part 1, part 2 and part 3 of the chapter Chemical Reactions and Equations. Write your comments if any in the comment box below. Like and subscribe my channel to see the notification of my forthcoming videos. Thank you.